All right, welcome pre-algebra students. This week we are moving on to some probability. So we're doing compound events, meaning more than one thing. If you're looking for more examples, help, look for what I have here in the box, IN-2, outcomes of compound events, and then off to the side here I wrote that outcomes of a compound event is the same thing as sample space. So if you ever see those two words, that means to list out every single possible outcome, okay? So I'm going to show you three different ways to find sample space: by a table, by a tree diagram, and by the multiplication counting principle. And I've kind of color-coded them so that I'll show you a table a couple times, a tree diagram, and then a multiplication counting principle. I have them color-coded, okay? I did some things ahead of time to save some time. This week I am writing on 5th period's Show-be notes, so your notes will already be done. And then the rest of the classes you'll have to go in and do your notes, okay? So first example here, Matt flipped a coin and he spun the spinner below. So how many total possible outcomes are there? And then also list each and every one. So I created a table. So make sure you know, guys, because it's going to be in your Pearson assignment, that rows go this way. So there we go. So the heads and the tails that I have here, that's my outcome of my coin. Those are my rows. And then columns go this way. All right. So the outcome of the spinner, oops, I didn't spell columns right. The outcome of the spinner is listed in the columns. You'll really want to pay attention in the Pearson assignment because when it tells you to list out every single possible outcome, it'll tell you to put either the columns first or the rows first. So be careful with that. So the outcomes, if we spin that spinner, we could get red, and then flip the coin, we could get heads. So we usually abbreviate, and you'll see the abbreviations in your Pearson assignment. So this means we could spin red and flip a heads. We could spin red and we could flip a tails. Okay? Now, let's say we don't get red. Instead, we get green. So green and then flip a heads, and green, flip a tails. Spin a yellow, flip a heads, spin a yellow, flip a tails. Okay? And this is a nice, neat, organized way so that we can see every single possible outcome. And then orange heads, spin a orange, flip a tails. So how many total outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total outcomes. Okay? And this is something exactly like you'll have to do on your homework. Okay? Now, let's look at a tree diagram. So I'm keeping it consistent up there. So Natalie flips a coin 3 times. How many possible outcomes could she have gotten? When you draw a tree diagram, I often see, okay, well, flipping a coin, there's 2 possible outcomes, so I see 1 and 2. No, instead, we want to actually list out what are the possible outcomes. So if we flip this coin, what could we get? We could either get a heads or a tails. Okay? Now, let's say we flip heads. When we get to the second coin, and maybe I'll organize this, I'll show you. This is the first flip. Okay? I'm doing a horizontal tree diagram. Okay? Now, we flip a heads on the second coin. Well, what are our possible outcomes? We could get, and I'm going to spread this out a little more because I know we have a third flip. All right? So again, we could get heads or tails. So this row is our second flip. Okay? Now, let's say actually we flipped a tails on that first flip. So our second coin, what could we possibly get? Well, again, we could get a heads or a tails. And they're all in the same row there. So that's our second flip. Okay? Now, we do still have 1 coin left, our third. So let's say we flipped a head on the first coin. Then we flipped a heads on the second coin. Well, then what are our possible outcomes on the third coin? Again, we could have a heads or a tails, okay? And then let's say we flipped heads first flip, tails second flip, third flip could be heads or tails, okay? And this row here then is our third flip. Okay, and again, just a different way to organize all of our possible outcomes. So after that second flip, again, our third flip could be heads or tails, and then here could also be heads or tails. Okay, so how we read this, I'm going to change colors and make it kind of real small. In our tree diagram, here's one possible outcome. We could get heads, heads, heads. We could follow the tree branches, heads, heads, tails. So there's a second outcome. We could get heads, tails, heads. There's a third outcome. And then we could get heads, tails, tails. Okay? And we could list out every single possible outcome. Heads, heads, heads. That's one possible outcome. Heads, heads, tails. Heads, tails, heads. And then heads, tails, tails. Okay? And then same thing over here. Tails, heads, heads. Tails, heads, tails. There's two more. Tails, tails, heads. And then tails, tails, tails. So there's four more outcomes over here. So how many total do we have? Well, then we have 8 possible outcomes. And off to the side here, I'm going to list out every single one. Okay? That's the purpose of a tree diagram. And a table, so we can see every single possible outcome or sample space. Okay, so we have, there we go, 8 possible outcomes. Okay, and then what we can do, guys, is use the table or use the tree diagram to find probability. Okay, so let's do this one here. We have Charlie picks a card from the cards below and then also rolls the number cube. So how many possible numbers could he get? A tree diagram is going to be a lot, so I'm going to do another table like up above, and I'm going to show you how I created that. Actually, I didn't keep my colors consistent, did I? That first example I did in red. I apologize. So let's see. We could get, with the cards, we could get a 10, we could get a jack, we could get a queen, we could get a king, and I think there was an ace. There was. Okay. Then rolling the number cube, we could get a 1, we could get a 2, we could get a 3, a 4, a 5, or a 6. All right, then what we do is simply fill in every single possible outcome. There we go. So one side, either your row or your column, will be the one event, and then the other row or column will be the second event, okay? So we could list out every possible outcome. We could draw a 10 and then roll a 1. We could draw a 10, roll a 2, and so on, okay? And how many total possible outcomes would there be then? So right there, 1, 2, 3, 4, 5, 6. We're going to have the same with all of our jacks. So 6 more. And then we're going to have the same with our queens, our kings, our aces. So 6, 12, 18, 24, 30 possible outcomes. Okay? And this is getting then to the fundamental counting principle, or we also call it the multiplication counting principle. What that says is that we can just multiply how many possible outcomes are there in the first event, how many possible outcomes are there in the second event, and multiply those two numbers together. And that will give us all possible outcomes, okay? Now, the fundamental counting principle, or the multiplication counting principle, will not tell us every single possible outcome like I am doing right here. It's only going to tell us the total amount, okay? So that's what I'm going to do in this last example. So this one we have 2 spinners. So this first spinner, how many possible outcomes could we get spinning it? Well, there's numbers 1 through 10, So there are 10 possible outcomes, okay? Then spinning this one, how many possible outcomes are there here? Well, there's 4. Multiply them together, there's going to be 40 possible outcomes. Okay? Like I said, it doesn't list every single one. We could organize it in a table or do a tree diagram. But if we don't need to know every possible outcome, the multiplication counting principle is the easiest. Okay? If we did it here, we had 1, 2, 3, 4, 5 cards. We had 6 numbers on the die. Multiply them, and that's exactly what we got. Okay? We have 2 possible outcomes for the first coin, 2 possible outcomes for the second coin, and 2 for the third. So 2 times 2 is 4. 4 times 2 is 8. Hey, that's exactly what we got. Okay? And same thing here, 1, 2, 3, 4, 5 possible outcomes for the spinner, 2 for the coin, 10 outcomes. So that's the multiplication counting principle. Okay? So all you guys have to do this week is the IN-2 Pearson Realize assignment. Thanks so much, guys.